Okay, hello everyone, welcome back. Today I want to quickly get the introduction done because I already know this is going to be quite a long video unless I split it up into parts. But today you're about to experience the very tedious process of inverting a 3x3 matrix. Again, it's allowed because it's a square matrix, and you'll see all the processes that go into inverting a 3x3 matrix. It's going to be interesting, but also a little tedious and something that you'll probably do rarely, hopefully. But anyway, let's start off. Inverting a 3x3 matrix. If you thought that the 2x2 matrix was tedious, you're about to experience something on a whole new level, trust me. So let's get started quickly. So let's establish a matrix. Let's see, we'll pick out some rather easy values. Let's see, so set this matrix equal to A, 3x3. So this matrix will be, let's see, so like 0, 1, 2, 0, 1, 1, 2, 1, 1. Sure. Just pick out easy values. So the first thing you want to do is you want to take from this matrix the matrix of minors. Now this part is probably going to be the hardest to explain, but you'll see. So the matrix of minors. Basically, I have to explain this on paper. So what you do is, let's give ourselves a decent amount of room. Okay. So what you do is, on each term you cross out, whatever term you're on, you cross out that term's row or column and row. See how I cover my fingers? So let's say we will start on the term 0 here. So as a result, we'll cross out the row and the column. We're left with 0, 1, 1, 1. Now, what you do with that is you want to, so this is the first term, right? What you do is you want to take the determinant of the remaining terms, so 0, 1, 1, 1, in the exact order. And hopefully you remember how to take the determinant. Tak? Babci, robię wideo! Sorry about that. So obviously the determinant sign looks like the absolute value sign. So now we do that for all the remaining terms. I'm probably only going to do this for a few of the terms. We'll see. So now we go to the second term. And again, you cross out that term's column and that term's row. So we're left with 1, 2, 1, 1. So take the determinant of that. 1, 2, 1, 1. Hopefully that makes sense. Now, third term, so cross out the row and the column. So we're left with 1, 0, 2, 1. 1, 0, 2, 1. Just like that. And I'm just going to do one more row and hopefully get the hang of it. Then we'll just take the determinant instantly. So this term, 1, you see? Now cross out the column and the row. Or sorry, cross out the column and the row. So now we're left with 1, 2, 1, 1. So 1, 2, 1, 1. Right? Let's check all of the others quickly. This one. Yep. This one. 0, 2, 1. Okay. Next term, 0. So this one, it's 1, 1, 2, 1. 1, 1, 2, 1. Right? Because okay, got it. Okay. So final term, and then we'll just start doing it instantly. So this term 1, cross out the column and the row. So we're left with 0, 1, 2, 1. 0, 1, 2, 1, right? Let's check them. So this one was 1, 0, 2, 1, and then 1, 1, 1, 1, 2, 1. This one, 2, 0. think we did this one incorrectly, actually. Because, sorry, so it's like, so cross out this row and this, yeah, we did this one incorrectly. 0, 2, 2, 1. 0, 2, 2, 1. Okay, there we go. Right? Okay, now, so now we'll simplify this. We'll take the determinant of all of this, and we're going to do this row automatically. So you do that for all of the terms. I just decided to take the lazy route. So let's take the determinant of this, right? 0 times 1 is 0, minus 1, that would be -1. So -1. 1 times 1 is 1, minus 2, that's -1 as well. 1 times 1 is 1, minus 0, that's 1. Right? 1 times 1 minus 2, that's -1. Oh, wrong. That's fine. So -1. Get a lot of -1s, it seems. 0 times 1, that's 0, minus 4. So -4. 0. Okay, 0 times 1, that's 0, minus 2, that's -2. So now we have to start this again. So now we're on this term, right? Cross out this, we're left with 1 multiplied by 1, minus 2, that's -2. Oh, minus 0, that's 1, sorry. Okay, now this term, cross this out. 0 times 1 is 0, minus 2, that's -2. Okay. Now final term, this term, cross out. 0 times 0 is 0, minus 1, that's -1. So let's check all of those. So this term, cross out this, 1 minus 0. So, yeah, next term, 0 minus 2, that's -2, and final term, 0. Yep, okay, it should be right. So this is our matrix of minors. This is just simplified, same step. So now what you want, okay, we're going to make this into 2 parts, probably. So now what you do is you multiply this, this is a simple step, by the matrix of cofactors. So all you need to know is this order, plus, minus, plus, minus, plus, minus, plus, minus, plus. It's like a checkerboard pattern with plus and minus. All you have to remember is that this first term starts with plus, and then you can start it again. So, cofactor. This is the matrix of cofactors. So all you do is, there's always a secret 1 there, right? You just change the sign of all of these according to this. So this stays the same, right? So let's write the new matrix of cofactors down. Now this will be, so this is equal to, this will be important later on. -1, +1, 1, +1, -4, +2, 1, 2, and -1. So that's our answer for the cofactors. So now you want to take the adjugate. So this is important. I'm going to underline that twice. Okay, so now you take the adjugate. Remember the adjugate, but now we're doing it with the 3x3 matrix. It's a little different, but it's really simple, trust me. So basically you take the adjoint of this, whatever you want. So this becomes, so the adjoint of A is equal to, basically what this is flipping this term across this side. All the diagonals stay the same, so we'll put them in. So let me explain this. So basically if you have a term on, this is, you see, we're going to look at 1 right now. It's row 1, column 2. Basically you flip that to column 1 and row 2. It's like flipping those terms. So all it is just flipping across the diagonal, the middle diagonal here. So this stays the same, 1 and 1. This stays the same. Oh, we've got an even matrix adjugate here, because it's not a very good example, but you see, we still flipped all of these terms across, but since these terms were equivalent, it didn't change the matrix at all. So, okay, so that's our adjugate. And remember our formula? I'll write down our formula here. A to the negative first power is equal to 1 over the determinant of A multiplied by the adjugate of A. And we've already got the adjugate of A. So all we have to do now is find the determinant, 1 over the determinant of A. So just the determinant of A. And the way you do that is you take your matrix of cofactors and your original matrix, and what you do is you take the first row, though theoretically it works with any row. But let's just remember this, just to keep it simple. So you take the first row of your matrix of cofactors and the first row of your matrix of your original matrix your 3x3 matrix that you wanted to invert. And what you do here, let's just take another paper so you can see that still. So we're going to take that, and what you do is you multiply each term evenly. So it would be 0 multiplied by -1, right? 0 multiplied by -1, 1 multiplied by 1, plus 1 multiplied by 1, plus 2 multiplied by 1. And the result will be your determinant of this matrix. So it would be, determinant of A would be 0 multiplied by -1 plus 1 multiplied by 1 plus 2 multiplied by 1. And that's equal to, right, 0, 0 plus 1 plus 2, and that's equal to 3, right? Yep. So this is actually our determinant. So we're taking 1/3 of all the terms. So now you see this is our adjugate here. It's equivalent to our cofactor, but that shouldn't matter. And let's find our answer right now. We're at 12 minutes. Wow, we're making good time. So, and this is also equivalent to basically the number here multiplied by the determinant, like this. So it's like, it would be equal to 0 multiplied by all the terms in the matrix when you get rid of the row and that term's row and the column. So 0, 1, 1, 1, plus etc., etc. for all the terms. But that's not necessary. That's a nice exercise if you want to do it on your own. So that's equivalent to this. Anyway, let's start plugging this into our formula. So a negative first power is equal to 1 over 3, right? Because that's the answer we derived. Multiplied by our adjugate, which is equivalent to our cofactor. It's -1, -1, 1, 1, 1, -4, 2, 1, 2, -1. And now we just multiply 1/3 by all these terms. So that's equal to, let's give ourselves a lot of room, just for grins. So -1/3, right? We're just distributing. It's like the distributive property of matrices. Just distribute the 1/3 across all the terms in this matrix. 1/3. Gave myself too much room. Should have spaced them out more. So these are different terms, by the way. 1/3. 1/3. Okay. -4/3. 2/3. 1/3. 2/3. -1/3. And this is our answer. All of them have the denominator of 3, which is interesting. But, so yeah, so that's the end of this video. Next video, I will present you guys with, well, we will see if I got this correct. It's kind of a lot of pressure on me, but basically, if you multiply, again, what we explored in our inverting a 2x2 matrix, if we multiply this by our original matrix here, we should theoretically get the identity matrix, which you remember was a square matrix, so we should end up with the square identity matrix, which is this. So we should end up with this if we multiply. So I'll see you in the next video. Should be uploaded very soon. Thank you for watching. Hopefully you learned something. So hopefully it wasn't too confusing for you. Have a nice day.